Hello everyone. We got here a MacBook which was already in 2 repair shops. The big ones they're not bad repair shops at all, so they're quite friendly, and they send it to me, or they referred the customer to me. It's a last effort for some reason. So this is 16-inch A2780 MacBook, so M1 Pro, which had water damage. So since then it was obviously ultrasonic cleaned, there was lots of stuff soldered and so on. I'm not personally a fan of ultrasonic cleaning because I only think it should be used in very rare cases where you already backed up your data and everything is already fine and you don't risk anything, because basically sometimes ultrasonic cleaning basically destroys the boards. Not a high amount of devices were destroyed like that, but still. The second reason is that after you clean it, you basically have you wipe all your clues, so it's much harder. So let's take a look on this board. So there are many places soldered, so probably there was water damage, or maybe it was, or it seemed like it should be soldered here to fix it. I have no idea how it looked before, but so we have this thing soldered. So now signs of liquid around SSD. This is very good. So here's some soldering happened around audio amps. CD 32 18s and 17s look untouched. So you may notice this is 3218. This is for this is common on 16-inch for the MagSafe connector. Okay, so the charger was already also soldered. So this is not ESL 9240, this is a different number, but basically that's the same chip, almost the same. I heard there's some compatibility issues between them, but not that critical. I believe here was some corrosion, so we see some signs of fixed corrosion or soldered stuff. Okay, so here we got 3.8 volt rack, maybe replaced, maybe resoldered or reworked. So looks like one pin is floating. I'm not sure if it's soldered. Let's put more light. All right. Okay, it's most likely connected, I think. Okay, let's look on other side of the board a little bit more. Okay. Okay, so this was soldered as well. This is 5 volt rack for the right side. Okay. Well, so let's start with the basic measurements. So the first thing you always check is the PP bus, if it's shorted or not. Easiest way is to go here on an input fuse. Okay, it's fine. So let's check the soldered stuff. So this 5-volt rack, if it's shorted. Okay, it's fine. The next main power rail on M platform is 3.8 volts, because basically, like on iPhones or like on iPads, the CPU power regulators are all working from the 3.8 volt. So this is like as if it was one cell battery device. So that's why it's in range of the battery voltage is one cell. But obviously all Macs, they run on 12 volts. So you have this 3-phase power regulator, which converts 12 volts to 3.8, which is later fed to all power ICs. Okay. So this stuff looks clean, unsoldered. I can't remember what this small rack does. I think it's 1.8 or something. Let's put it. Where's my module? Here. Okay, this is 5.2 S2 rail. So it was pretty soldered. Okay, good, not shorted. Okay, it looks right. So the board wasn't cleaned. This is after the last soldering, so it was probably the first thing. It was ultrasonic. It didn't work. Maybe there was some repair attempt, and then it was sent to another repair shop. They tried more soldering, still no luck, and now it's here. Okay. Let's check some more stuff. So here we have the secondary PMIC, which is soldered. So before we even starting to work on it, let's check the. Okay, now let's clean this first, because this is quite messy here. Alright. So probably secondary PMIC was replaced. I have no idea why. Maybe it had water damage in it, maybe not. Because I don't see any signs of corrosion on caps, because usually you have like gray caps. Okay. Now let's check coil's resistance to ground. And let's hope we won't see any short circuits in CPU. So this one is a little bit low. It's 40 ohms, but I believe it's in proper range still. I really hope so. This is PMU box. This one goes to, if I recall, it's for the memory or net. This is for SoC. I think this one would be for memory. No? Ah, okay, this one. They are all for the SoC. Display awake. Okay. 56. Let's check if I have open board data on it. Okay. Oh, we got open board data. And we have some measurements. Okay, 47 looks good. This one should be 68. It's around right. Shouldn't be exactly the same because it could be a different memory vendor or whatever. Okay, but anyway, it's good as it seems not to have any soldered or glued together pads, because if you look at this stuff here, you will see that there are ground pads, like lines which can easily be shorted to ground. So this is important to check. So I already soldered, not soldered, I already screwed in the USB-C cable, just so I can use it all the time. I can rotate the board without it unplugging from the device. So it's fine. And by the way, let's check the port itself. Maybe some other ports. Okay, looks good. And the right side, because the right side is very sensitive. Maybe we have bad CD3217 here. Okay, it seems to be fine. Alright. So the next step would be to power up this board and to see what's happening here. I guess I will need thermal camera for this one. Because most likely we will see something happening on the power sequence. Okay, so let's plug it in. Let's see what's happening. So we already checked if there are any shorts, if the soldering of the secondary PMIC is fine. And now let's plug it. And nothing. Also, it seems that I have a broken cable here. Okay, there's something happening on the board. Let's check if we have PP bus. We have nothing on 3.8. We have 3.8 on PP bus. That's interesting. 3.8 on PP bus. This is... I'm not mixing it. This is indeed... Okay, that's interesting. So board U doesn't really match this board. This is sad. Alright, let's look somewhere else. Because we have another collection. What was this once again? 2780. Okay, let's check this one. Okay, and this one seems to be the right one. Yeah, this is PP bus are on. Okay, so we have 3.8 volts instead of 12 volts. This is quite interesting. I hope I will not have to replace the ESL chip. because I don't think I have the same one, and it's still not 100% clear if 90-40 is completely compatible, but at least 90-40 will yield proper PP bus no matter what. Okay, and we don't have the schematics. Okay. Okay, this one is the schematics. Let's download board data again. Okay, does it? Okay. No. Okay, whatever. Okay, we lost our PDF, now it's back there. Okay, so yeah, this was PP bus. So first let us address the PP bus problem. So let's see what's happening here. So we are going on the other side of the board. Let's rotate it and let's look. Because basically, as I mentioned many times before, the ESL 9240, oh crap, come on Windows, I know you can do it. Yay. Okay, this chip is pretty stupid. I don't know, it doesn't do much stuff. It generates 12.3 volts per default, and it should do it no matter what. If it has 5 volt inputs, it boosts it. If it has 20 volts input, it step downs it. Okay, so this looks really messy here, so let's clean it. And let's put a microscope on top. Yeah, this all looks like it was never loved before. So our main point of interest would be to check if the chip is working properly. So 9240 or this RA489900 is basically the same as 9240. So to check if the chip is fine, we always check if it has its own internal 5 volt LDO, because usually if it dies there will be no LDO. Let's check. And we have 4.4 volts, which is a little bit low actually, because usually it should be somewhere around 5.5 volts. Okay, let's check what's happening on this cap here. .4. Okay, I don't think it's supposed to work with lower VDD voltage. It seems wrong to me. And there's also what is this thing? So we have internal 5-volt supply, and we also have some sort of bypass which will use 5-volt S2 rail to power up this chip. So on older T2 machines, as well as 13-inch M1 machines, it wasn't the case. It was also always self-powered. But here we have switch. Let's see what's happening here. Let's see what is this one, what this does. So 4.4 is definitely not the right voltage. V out. Charger and lower current flow. Discharge signal that doesn't load charger LDO. Okay. Interesting. So they made it much more complicated here. So if we have 5-volt S2 main, it enables itself. It goes out, 5-volt charger. It goes there. It goes here. And this one... It doesn't make much sense. Ah, okay. VSTPS power good. VSTPS power good. What is this one? So if the 5-volt S2 main is good, okay. I'm not sure if V in and V out is properly described here. The first thing we have charge and the overdrive current flow, and we have a V out here current flow. Okay. Yeah. Okay, I think first we will remove this chip because it's not really necessary for it's not really that necessary for ESL to turn on. As you may heard, I use max temp because this board is really fat one. And I also think I got some... Is there anything here? Okay, it's solder. Yeah, this board generally looks like crap. This place. There are lots of stuff which needs to be removed simply before we go anywhere further. Like such caps, they might work, they might be partially shorted. Okay, so I believe this whole circuit is intended to isolate ESL from the 5-volt discharge circuit. Because on Apple, on some power rails, like on 5-volt rails, there are so-called discharge circuit, which effectively discharges 5-volt once device is off, and this is part of this circuit. since we have 5 volt connected to the LDO of ESL9240, we need to isolate it in the case if we don't have, if we have the discharge. I believe if we have no enable on the 5 volt S2, which would also enable discharging this circuit, then it should disconnect this from the ESL9240. So this is whole idea. But for now it's not really important for our repair, because we only need to get to the proper PP bus first. Okay, now let's put it here, so we won't lose it. Okay. Now the whole place doesn't look really nice to me. Okay, now let's put the cable in and see if we have 5 volts on this LDO, because now it's supposed to be disconnected. Okay. And we still have 4.4 volts. And that's not a good voltage. It's not what we need. We have 3.9 volts on outputs, 5 volt on input. Okay, let's see what's happening on the aux line, aux detect line, but I think it would be also fine. Okay. Most likely this chip was already replaced, so maybe no need to replace it. But I guess I'm gonna replace caps, because maybe one of these caps are not having enough capacity to generate proper voltage. Okay, now let's see what's happening on aux detect. Okay, so cell pin also tells this thing what exact configuration are we here. So if it's low, it's 2-cell configuration. If it's high, it's 3-cell configuration. It's 4.4, so probably it should be read as high, I believe. But anyway, if it's seen here like 2-cell configuration, we would see 8 volts on PP bus, but not 3.8. Maybe if it's 0, we have 3.8. Maybe it's supposed to generate it. Let's check it with our oscilloscope. I don't have it on screen, but I will simply check if there's something happening on the gates. Let's go here. Charger. Okay. We have a nice test point here. Thank you, Apple. And we don't have any power here. Turns on the oscilloscope. Alright, we have a small one. Just forgot. Now this one is pretty laggy and so on, but it's good enough to check. It's good enough simply to check if we have some thing going on gates. Okay, so this should be our test point, I believe. Okay, and basically on this gate we have 4 volts, which is not good. Let's check this gate. And there is nothing. Of course, because this one is okay. This one. Let's check here. There is nothing on this gate. Okay, so effectively I have 4 volts here. Let's check if there was, I think MOSFETs were soldered here. I have no idea why, but maybe they're flipped or whatever. Okay, now let's check the resistance. It has 0. I'm measuring wrong parts. It has 0.5. This one is fine. Hello, why are you shorted? Is it even possible to short this thing? Let's desolder and then check. Honestly, I never seen PV bus MOSFET shorted. Maybe once or 2 times. I can't really remember. They might seem shorted if you have like some residual charge on them, but I switched to the side, so it should be fine. This is a really fat board. has so many layers and so many ground layers inside of it. So to desolder even a small component from it, like I'm using the maximum temperature of my quick, and as you may see, like I can't even remove this small cap. It's not even melted. Let's help it a little bit. So we got it off. Now let's check the MOSFET. Or first let's check if this short is gone. Okay, the short is gone. I would be really surprised if it's not just me being stupid, not able to properly mirror it. Most likely it's just me being stupid because I'm not sure I discharged it before mirroring. Oh. Wait a second. Let's charge it another way. Yeah. No, it's fine. Let's check it once again. So let's charge the gate. Gate is now charged. We have conductivity. Now let's discharge it with a black probe. Now we don't have conductivity. Okay, it's completely fine. I'm just stupid. Okay, but let's see if gate is connected somewhere, because it should have been discharged itself. Should have been discharged. Okay, it's not open line. That's for sure. So it makes its way to the ESL. Okay. So why is ESL opening this thing just partially, like it pulls like 4 volts or something to it? Maybe let's replace it. Let's put some fresh silver. I wonder if it does the same on the lower FET. Charge. No. And diode. Okay, let's put it back. Maybe there's something wrong with ESL or it's soldering, because on the other gate I have 0.4, not 0.89 voltage drop, which might indicate some problem with ESL controlling the case, because I believe they should be the same readings. But let's put it back and check if it's true. Let's solder it and let's clean it so no one will notice that we touched it uselessly. But I'm not sure I'm supposed to be able to charge it in circuit. Yeah, we have different readings on under the diode mode. I think I'm gonna take a donor board to make sure. Alright, so after some useless stuff being done to the board by me, let's get back to the repair. And also I forgot to put Microsoft on myself. I'll try to correct the audio later because it was nearby, but whatever. Okay, so now what I'm gonna do, I want to check if we have the same diode drop. I believe these are 4 pins for gates. Let's open the new window, new instance of BoardView, and check it real quick. So the charger gate Q1. Charger gate Q1. Okay, I think we found the problem. So as you may see, this is the same gate, which is 0.4, obviously same as the other gate, and on this board we have different voltage drop. So the first one is fine and the second one is 0.8. So this is definitely off. So let's replace it. Let's put 9240 on it. Maybe it's simply corroded or whatever. But it already has like two not really good symptoms. So the first, it has 4.4 volts instead of 5 volts, or even 5.5 for its internal LDO circuit. It doesn't really control the gate. It just has like 4 volts on this gate. This was the one. I wonder if the only thing I have to fix here is PP bus. It would be way too easier. There's also so much done to this board. This was soldered as well. There are like bolts flying around. Okay. Let's clean it up. It's also a perfect example of data-focused repair. Because even if I manage to fix it, even if I get the data, I'm not sure about anything done to this board and to the cleaning and so on. So I can't really guarantee that this board will work fine. So I'm only doing it because the data is really valuable on this device. Okay, it's clean now. Maybe it's even fine. I'll put a white dot on it. Also, I think there's something missing here. Not sure, there should be 2 resistors. Okay, they're just shifted a little bit. 2 resistors and a cap is not necessary probably. Just the charger detect. Okay, now it's fine. Okay, great. Still some gunk here. Okay, now let's check if gate pin was connected. This one should go to the test point. Let's check it. Okay, it goes to the test point. This is fine. Okay, so all pins seem fine to me. Okay, now let's take this chip because it's known good, ESL9240. But I'm not really sure why so much stuff was soldered when device didn't have even PP bus. I mean, what's point of soldering 3.8 if you don't have PP bus? It's not getting there yet, and it won't really change anything. This one will be really hard to desolder. I have new chips in real, but you know, if there are chance that you get a bad chip in the real, it's not zero. It's better to take a known good, because this one had a problem with the Wi-Fi, also some other issues, and this is my donor board, and I know 100% that ESL9240 was fine and working. the heat dissipation of this board is absolutely insane. I mean, only to remove this chip you need like the full power of your hot air station, and you need like a couple of minutes until it even slightly moves. As you may see, for example, this one is not moving. It's like 500 Celsius on maximum for quick. Okay, now we got it. Now let's reball. Oops. Okay, so we got our reference ESL chip. Let's rebolt the, or let's check the original one. For example, just to be sure that it wasn't like the soldering problem with the voltage drop. So let's find the pin. So this one is on the opposite side of the first pin, and it should be ground next to it. Okay, let's clean it a bit. Okay. So there should be 0.4 voltage drop here. So this one is not connected, so the ground should be 1, 2, 3, ground. Okay. 1, 2, 3, 4. Okay, maybe this is not a good ground point. Here there are 3 grounds, 1, 2, 3, 4. 1 down. 1, 2, 3, 4, 1 down. Okay. It's 0.4. And this one is open line, which is not right. Okay, yeah, problem with this chip is really bad. Okay. Okay, now let's check the current sense loops. This is CS current sense input. So we measure here. There should be something around 2 ohms. 3.4, okay. 1 ohm. 1 ohm. 1/2 ohm, okay. Okay, these are just my probes. Okay, the second current sense is here. So it'll be charger output, these 2 pins. Okay, same. Okay, let's check the capacity. So 10 microfarad. Okay, it's fine. So the capacity seems also to be fine. Let's check the both resistors. 4, 1, 4.7, 1. Okay, these 2 are also fine. Okay, probably I'm gonna end up replacing all this stuff simply because it's not a good idea to let corroded caps to sit on board. They might get shorted later, but they are not high current or high voltage caps, so for now it should be fine. Okay, now let's put our 9240, and this one is revision B3. I also heard it's not compatible with older ones, but I'm not sure. Maybe they did change something like, you know, like the E2C address. Need to check in the schematics later. But for now it's not that interesting because we only needed to generate a PV bus for us. That's all we need. So basically the theory is that the gate was floating, so because of the problem with ESL chip, it was floating, so that's why it opened and that's why it wasn't discharged as I removed the power. So it seemed to be a short circuit. Obviously this is a rookie mistake to measure short circuit on something which is not shorted, especially on MOSFET, which is simply open because of its charge. But alright, let's let cool it down, clean it a little bit, and measure again. Okay, now we have 0.4, 0.4, 0.8 still. Then it was a wrong clue. So 0.8 is fine. But since we already replaced it, let's check. And this one will be rebought, so let's put it here so we don't lose it. Okay, now we have 5 volts at VDDP, so it's already a little bit better. Let's see what do we have on PP bus now. And we got 0. Nothing going on here. We got absolutely nothing. So we got our input. We got our 5 volts. I'm not sure, it's supposed to be 0.8 volts. This is aux detective, I get it, yeah. So this is should be approximately a third one. 1/3 of the voltage. We have some residual voltage, so which means that it was trying to put something on PP bus and then it stopped. Okay. Let's try to check if it's soldered properly. Maybe it's not simply not connected with all points. So now it should be definitely connected, or maybe even so connected that it's shorted underneath it, because I wiggled it quite a lot. Yes, this one is missing, but it's not bad. Oh, the power meter is not working. Here we go. No output. I don't think this is a proper voltage here. 0.8. Let's move resistors and check if they are fine. Also, what about this diode? AUX detect short. That's interesting. I don't think I've seen it implemented in other boards, so it's detects short circuit. here. Let's move it aside, because we don't need to detect any short circuit now. So 16-inch board is slightly different from the 14-inch. I don't work often on such boards, because such devices are probably rare. Need to move both resistors to measure them off circuit to be absolutely sure they are fine. Because if I recall, we should have something like 1.4, 1.3 volts, and the threshold is around that. So even soldering such small stuff is hard on this board. Okay. This one measures 0.7 mega ohms, which is fine for the higher part of this divider. This one is 156, but it should be 255. Okay, so this one seems off. Well, still there might be an error in schematics. It's possible, but maybe it's not. Crap, I need fresh solder here because it simply won't melt. So if it's lower resistance, then we will have lower voltage, which is exactly what we are having. Put it on here. Let's check if there's an error in schematics. This also has Same circuit. It's 190. Two. Okay, let's get it from donor. And also check if the one from donor has 150 instead of 250. Believe it or not, this is maximum temperature on quick, and this is like 0201 component here I'm trying to remove. But one side of it is on ground and the ground plane is huge, so even such tiny component is really stuck on this board. This is absolutely insane. The first time I soldered this board, I really thought that my heat gun is broken. Yeah, that will do. Let's see what voltage do we have now. Oh, we have significantly higher power consumption. And maybe we even have a PB bus. Yeah, we got PB bus 12.3. And the proper voltage here is 1.2 volts. Okay, so now we are one step further. Now let's check if it was really the resistor problem. Okay. You'll also probably need to put the original charger back to the board because it wasn't faulty. It simply is that on one of the gate outputs it has different diode measurements, and because there's a different type of the MOSFET on the other board, it has the same. On this board it should have different, and this is normal. Oh, there was the false resistor. Let's put diode back to the board. But as you probably figured, we don't really have the full power on, so we still not fixed the board. Even so, we have PB bus working now. Okay, now we can put all this stuff back, because now we figured that it wasn't fault. Now we have to figure if the discharge circuit was also faulty. I don't think so, because most likely we had a problem with charger and we had a problem with voltage divider. Not 100% sure about the charger, but still it had 4.4 volts instead of 5. And maybe this LDO is used somewhere in the system, I'm not quite sure. So we need to put it back. Need to look a little bit deeper. Alright, let's turn it on and see if we have more voltage. Okay, so we have 5 volts here, 12.3 here, so that's all good. We don't have 5 volts here. Not sure if we're supposed to. Okay, now let's move on to the next power rail, the 3.8. So the 3.8 is most likely not present. Then there will be 5.2, so basically everything what's soldered here is on our own list. Oh, we have 3.8 volts. That's some great news. That's some great news. So now you have to figure if there are any outputs from the main PMIC, and obviously there's none. Otherwise we would see much better power consumption. But there's nothing. Okay, so we have 3.8. Let's see if we have 5 volts. It's a little bit too early for it, but let's check if we have enable for a 5 volt rail. Because the 5 volt was also, it's also soldered. TPS power enable. Okay, the third one. This one is enable. No, we don't have enable. Okay, let's check 1.8 always on. It's also a very interesting line. It's there. No water damage or whatsoever. Someone measured shit out of this chip. I wonder. I think this device also had. I think this device also had PP bus before. So something happened and it lost PP bus. So now we are into the rabbit hole of figuring out everything what could be wrong with this board. Let's clean it again and again and again and sync. Okay, now the next step would be to look around the main power IC, because main power IC doesn't need much stuff to work, but there are some test points we need to measure, and I think I see why it's not working. And maybe this is the original issue which was overlooked. As you may see here, there's some nasty corrosion here, and I will show you exactly what this place is. So I'm looking here because I know that this is often gets corroded. This is PMU VDD HI, so this is a in some sort of voltage sense or reference voltage made by voltage divider, and it's obviously completely gone here. So that's why we don't have any power on the PMIC. So the PMIC actually needs very few things to turn on. So the first thing, it needs 3.8 volt inputs. The second thing, it needs VDD high. The third thing, don't probe PMU VDD high says it's. Let's check. It's really nice here. Don't probe PMU VDD high. Don't probe it. Impedance is very high. Well, we will probe it and it will work, but I wonder if this is just a test part I'm scratching here, or it is there's a via underneath it, because it's also disconnected here. As you may see, a part here is completely gone. Maybe resistor is fine. Let's fix the pad. And let's check if this is supposed to connect to something. So the easiest way to check connectivity is to use, okay, PP bus are on PMU. Probably this is just test point. Because, so basically, if you have some line which is connected somewhere, you will find some internal diode, or maybe this is like some sort of, that would be like parasite diode in MOSFET, or you will simply find a diode in logic. Okay, so this resistor is not good anymore. So this one is a high side resistor. So it should be either 1.1 mega ohm or 1.07 mega ohm. Use 1% precision. Let's try to measure it. I think there's some flash to solder on, so we can check. Because I'm not quite sure which type is used. Because free cell in 12 volts is effectively the same voltage. So I'm not quite sure what they meant here. Okay. I think it's 0.7. Okay. Definitely not. Yeah, it was 0.7. Okay, let's scrape it. I probably have it in book, but let's simply scrape it. And let's hope that PMIC survived it, because I had few boards where PMIC was actually killed by high voltage on VDD high. So if we replace it and we still have no power, that would mean that we have bad PMIC, and I'm not sure I have it stocked here, but I will try to find one. Now let's check again. Yeah, that should be fine. So this place wasn't touched, and as you may see, it was a little bit harder to see because of the ultrasonic cleaner. If it wasn't cleaned, it would have obviously something visible here, like a clear marking that this is important. The second thing I'm gonna check before doing any further text is BST on Q. It's not there on this board, it's only the thing on the 13-inch devices. Okay. I think I forgot it. Okay. Now let's get some power. Oh. Let me show this to you. Where is the power meter? Here, no. Specs there. Okay, now we have something going on this board. So we have 20 volts. And we have changing currents. Okay, so basically, most likely the only problem this board had was this small resistor. And all this soldering could be avoided. I'm not sure, maybe there was some stuff like corroded and restored and so on. So now, as we have power on, we will do data extractions first. Once we have all data, we can remove the board once again, and I will probably finish it because I gave customer 2 quotes. I told him that probably I will be able to get data, and if I need to do further, I will have to redo lots of stuff on this board, and this might cost more time and more effort. So there are lots of partially corroded caps which needs to be replaced. It's not necessary right now before we get the data, because I don't see any caps on the PP bus line which are corroded. So we don't have like high chance of getting short. Okay, let's see if we have Apple logo, because if it won't boot, will be still, there will be still trouble. Okay. So this is really a good example of why ultrasonic cleaning is not productive. Because if instead of ultrasonic cleaning the first service would have fixed all obvious water damage they seen, and it was like obviously there was some corrosion spots and there was maybe like green gunk on the place which I fixed right now, the board most likely would have worked. So basically ultrasonic cleaning made the job much harder, not easier. It doesn't restore any corroded components, it doesn't restore any corroded things, but it does remove your clues to find where to look. So if you are good in power sequencing, if you know some stuff in power sequencing, I wouldn't say I'm good at it or something like that, but you can basically clean it, yeah, and you can just move through the power circuit and you see, okay, we have 3.8 wire, but we don't have any CPU powers, so where I'm going next, and you go to the power PMIC. You know that PMIC needs VDD high to turn on. You check the VDD high, and no matter if you cleaned it or not, you will see what's happened. Okay. Now we need to screw the battery in. I wonder if the battery will charge with the wrong charger, because I seen in chat like people discussing if it's compatible or not, but it didn't seem to me that there's like a definitive answer to that. What I want to see is basically Apple logo, boot process, case of the battery, connector probably needs replacement. I think I wrote about VDD high like 3 years ago as I first started to work on M1 machines. It's on wiki. Like it literally says check this thing if you don't have powers. And I think I heard the guy from the first repair shop, he complained that Logi wiki is kind of not that good, because there's no like step-by-step instructions on it and so on. But well, if he did read it despite it not having instructions, maybe he would have known that VDD high is important. But yeah, it's not that you know, like friendly. On LogiWiki you need just to read it, the page, and read it once again and once again, and maybe something will stick to your mind, and maybe you will find a solution. But there will be no like straightforward solutions like check this if you have this power consumption and so on. So on repair.wiki there are like lots of much simpler steps to check. They're useful, I think. In many cases they are useful, but they don't really provide you the understanding of the sequence. Okay. Okay, so we only need to get data now. Once we have everything backed up, we will clean the board once again. I will replace stuff and so on. I'm not sure it was filming. How do I clean the board? Because this is once again like raw repair, raw diagnostic from this beginning. I thought it would be much harder board to fix, actually. But yeah. Okay, so it doesn't have sticky keyboards, it's nice. Okay. Okay, so we have the Apple logo. It starts to boot. We don't have sound, so maybe there's something with sound. Maybe it's not. Okay, I have a mouse. Okay, so the left fan control is broken. Oh no, right. Okay, right fan is broken. Let's plug in the battery. Oh, we have the battery charging. So at least we have diagnostic message which tells us we need to reinstall the system, but we'll just start it new. Most likely audio will be broken because there was something soldered around the audio, or maybe we need to replace audio codecs, but it's not like the most critical thing here. We have boot. And it restarts, okay. So not quite there yet, aren't we? So let's try to get to the recovery, because you can also back up your data under the recovery. No recovery. Okay, there's some weird stuff going on with the power meter, as you may see. But it's probably because I have a 100-watt cable on one place, like between the power supply and the meter, and 80-watt cable between meter and device. So let's unplug it. Yeah, so it's simply dead battery. So let's close it and let the battery charge a little bit. Because I want this device to see something useful on this device. One port is also dead. So maybe I will have to charge it first. So now we have 88 watts charging current. And if we open it, it has it just resets itself. Okay. All right. It's kind of sad it didn't have the start sound. I like hearing start sound after the repairs. But Apple logo is also fine. But the start tone is, you know, like, it's musically fine. This is really current going on into this battery. This is a really fat battery and it consumes like 88 watts just to charge the battery. This is insane. So that's why it needs these two fat MOSFETs. Huge MOSFETs. But it's not really hot, it's like 40 Celsius. The current sense is quite warm. Oh, now we are by 91 watts. Yeah, it tries to squeeze everything. Okay, so now we have the logo and we can log in. Okay, so I will still let it charge because it seems to me that the only one port is working. Or maybe the second one, I need to put it on board. But that's it for today. I think the repair is mildly successful, because we got, most likely we will get all the data, and I think the device will also work in full its glory. And also I think I'm gonna charge battery externally as I work with this device, because I would do a few more things on board, because I didn't like how it looks around audio amps. And to backup data, maybe it's also a good idea to have like some battery. All right. See you in the next video.